back in. Energy and atmosphere. All right, so energy and atmosphere. There's a lot of concepts within this. I like to break it up. These are three big topics in sustainable design that deal with energy, efficiency, renewable energy, where we're getting it, how we're maintaining our buildings. So speaking of maintaining our buildings, commissioning. Fundamental commissioning is required in LEED. You can get some points for enhanced commissioning. And measurement verification, so going in and actually checking the building a year later and making adjustments based on certain code standards. In energy, there is a prerequisite for minimum energy performance. There is a point, or there's many points associated to optimizing energy performance. We looked at that credit weighting, and we'll get into it again, but that's where those 20 points slide, where you get halfway to certification with one credit. On-site renewable energy, heavily weighted as well, important for the future. And refrigerants. Refrigerants are something that really have been overlooked and are very harmful to our ozone layer. So we'll look at that as well. So commissioning. Good definition, no, very important to sustainable design, because this is really making sure that the systems we spec, how we design the building to be operating, is actually set at its optimal settings and actually installed in the building correctly, is actually reacting to how the occupants are using the building. So definition, the process of verifying and documenting that the facility and all of its systems and assemblies are planned, designed, installed, tested, operated, and maintained to meet the owner's project requirements. So once again, something that you have to address early on. The owner's project requirements are something you need to do ideally in pre-design, where you sit down with the owner and you really set these goals so you can get the team to stand behind it with their own basis of design that then gets checked and adapted throughout the process. And that's essential and actually required of every LEED project. So fundamental commissioning, you're looking at HVAC, lighting, domestic hot water, renewable energy if you have it at a minimum. And there are a lot of benefits of this. This is one that can have some upfront costs, but operation cost savings have been estimated at about 5 to 10% by some case studies and people reviewing it. So there's a lot of things that can happen. You're basically just setting your systems to run at their optimal point. Minimum energy performance is important as well, because this is a prerequisite. It's required for every LEED building. This is an important standard to know. We're talking about how to verify these systems. So how do they compare to ASHRAE standard 90.1? This has now changed to 2007. This is the updated version since the last version of LEED. California Title 24 is a more stringent code, so you'd actually want to compare against that if you're in California. And schools can use EPA's Target Finder. So this is new, that not just meeting the standards enough. According to LEED, you have to improve new buildings by 10%. They have to be 10% more energy efficient. And major renovations, remember that is an option for new buildings if it's a major renovation, not just the systems in the envelope. It is actually 5% improvement against code. If you're a core and shell building, you have to only improve the systems that are within your design control. Clicker kind of has a mind of its own. All right, default process energy costs. So you don't have to calculate everything yourself if you're using the LEED rating system. It's a good gauge of some approximations that help inform design. So according to LEED, default process energy is 25% of the total energy costs of the baseline building. So instead of having to calculate how much you think office equipment is going to be, computers, elevators, refrigeration, laundry, it's letting you estimate it. So you don't have to predict all of those different factors. We talked about refrigerants being important. So fundamental refrigerant management is a requirement of LEED. So refrigerants are what's running our HVAC system. So they're all around us all the time. There's a lot of harmful ones out there for us in the atmosphere. So CFCs are the most harmful. Those are now outlawed in the US, but our old buildings have it, so it's good to address that when you're retrofitting a building. So those are chlorofluorocarbons. Everybody say that together. So that has the most ozone depletion potential, ODP. Hydrochlorofluorocarbons, close second, but not yet outlawed. So natural alternatives, thinking about other ways we can do it. Maybe ammonia is less ODP. Desiccant cooling, carbon dioxide and propane have low levels. Optimizing energy performance. So here is that huge opportunity for cost savings. So there are a huge degree of where you can earn points. You can start at 12%, start earning 1 point, and the more efficient you get compared to that ASHRAE 90.1 standard, the more points you get. 48% more efficient than code, 19 points. The Burnside rocket we were talking about that has the edible garden, they're using a geothermal system and some other innovative ideas looking at the building as a system. They're saving 50% of their energy. So they're saving every month on their energy bills. But also, I'm sure they got lots of incentives associated with that, and they got the 20 points total adding in that innovation point. So energy, very important. That's kind of illustrating that weighting system that got addressed in LEED 2009. So first, you want to reduce demand. So that has to do with your building orientation on site and how you're maximizing those opportunities in terms of solar gain, blocking direct sunlight, letting in indirect light. There's a lot of design things you need to be aware of and how you're oriented on site. Maybe natural ventilation is an option. You want to be looking at which way you're getting the most wind. Harvest-free energy. So that's using things like passive heating and cooling, maybe having something like this concrete floor that's actually absorbing some of the sunlight coming through your windows and releasing it when it's colder at night, things of that nature. And increase efficiency. So here we're talking about systems. We're talking about the mechanics of the building more. Recover waste energy. So if you are doing something like supplying more ventilation into your building, good thing. Better air quality in your building, but maybe that requires more energy. So in that case, you want to do maybe like a heat recovery system. And what that does is basically the heated stale air that's exhausting from your building preheats the fresh air coming in. Never touches. It does a little whoop-de-doo and comes in just a little bit warmer with less energy to get it to that level for the indoors. And so, and then on top of those strategies, you want to start looking at renewable energy opportunities to supply clean energy technology, because the price of energy is going to continue to go up. So why not manufacture your own? Radiant cooling. Cave dwellers have realized this forever. Basically, it's what we experience when we walk through a grocery store and you go by the freezer section and you feel cooler. It's because your heat is actually being emitted to that cold surface through radiation. It's a very efficient way to do things. Radiant heating in a floor actually is much more efficient than heating the air, especially from the top down. And you actually do feel that sensation because you're basically balancing out with the temperature of the other surface. So if it's cool, then you're getting cooled down by it. If it's warm, you're getting warmed up by it because you're releasing the inverse of that. Renewable energy. So this is the Center for Health and Healing, OHSU's first platinum healthcare building. And here you see some integrated PV panels. And it's also the shading. So they're working with the idea of passive system. They're blocking direct solar heat gain on the south side by those overhangs. So that sharp angle is not coming in during this season right now in the summertime. And it's actually collecting the sun's energy that's blocking. So there's synergy right there in how they design the system. So don't just plug these things in randomly on your building or on the site. Think about how they can be affecting more than just one thing. So solar thermal, PV, wind, geothermal heating, biofuel, wave, low impact hydro are all renewable systems. Note that if you're talking about passive systems, architectural features, I described a little bit about passive heating, daylighting, geo-exchange. These are not actually renewable. They're not producing energy. That's what defines the renewable energy in the LEED rating system. So GeoExchange is different than this geothermal heating and electric, because all you're doing is using the Earth's constant temperature a few feet underground, depending on where you are in the world, to either preheat or pre-cool that air or water that's going through the building. But you're not producing energy. It's helping a lot with energy efficiency, but you're not producing energy, so it's not renewable. Here's an idea of how many points you can get in the LEED rating system, up to 7 points, 8 with ID point for 15% of your annual energy use being supplied by renewable energy, and that's a percent of the building annual energy cost. That's what you're comparing against. Once again, it's supplying measurements for us to do these high performance buildings. So it's based on energy calculated for either energy and atmosphere credit 1 that we looked at, optimizing energy performance, or you can use the commercial building energy consumption survey. And that's actually just a great resource because it just gives you typical averages and how much different building types use, how much energy they use per square foot. Just a great starting point. Some images of PV panels on the Eco Trust building in Oregon. Different variations. Is thin film, easier to apply to a retrofit, don't have the weight issues, and you don't have the wind uplift issues underneath a tilted PV panel. It's a great application. Different efficiency, but you'd have to do a cost-benefit analysis of what applies to you, because it might not be as efficient as some PV panels, but the benefits, how easy it is to install, might counteract that. Evacuated tubes, solar thermal. Pool heating. This, with incentives, is very cost-effective. Kind of one of those no-brainers, if it's done right, once again. Enhanced refrigerant management. So looking at synergy again, natural ventilation, good for humans, good on the social aspect, good on the economic side of things, because you're saving money, not having to heat and cool mechanically, and also you're reducing refrigeration because you don't need it for naturally ventilated buildings. So you're saving that headache of trying to find refrigerants that don't have ozone depletion potential or global warming potential. So this is actually an image from the Kelly Engineering Building. This is actually a vent on the top of the central area of the building. So it's venting warm air out the top because warm air naturally wants to rise, stack effect. They vent that out and it's naturally cooling itself. And in this climate, that's something that is very doable. 80% of the time, we can be bringing in fresh air way more than we do. So this is the ugly calculation that comes with this credit. Get 2 points for it though. But really, the point of this is you need to reduce life cycle ozone depletion potential. That's what LCODP means, and life cycle direct global warming potential. So 1 plus the other times 10 to the 5th, lots of zeros, has to be less than 100. So you get the picture. You can't have much at all to apply for this credit. So you have to be very responsible about the refrigerants you're choosing. Here's an example. Look at a little case study here. So this is the Hawthorne Fred Meyers. So Fred Meyers has really taken initiative to start implementing some of these sustainable strategies, and they're looking at the data. They're informing themselves about what's working best in their buildings. And one of their pilots was Hawthorne because the culture of that community really supported it. They're very environmentally conscious. They appreciate the effort, and that helps with their sales. So you're reacting to the community you're in, you're doing good for the environment, and it helped their bottom line immensely. You could see from capturing stormwater, putting night screens over their refrigerated produce, low-flow toilets and sinks and faucets, having occupancy sensors on things like the cake counter that don't have to be on all the time. Through all these different strategies, they spent $275,000, but they save $250,000 a year. So they're going, this may be a good idea. If we do this on a mass scale, imagine the savings. And that's really my hope in general. This is really where we're going to make an impact. If people start catching on to all these benefits, we're going to see this on a level that actually makes some really positive changes. This is a great product for many applications, high recycled content in this flooring, but it's bubbling up because it wasn't durable enough. It didn't take into account big crates and things being hauled over that floor in a big retail store. So it's having some maintenance issues that are going to cost. So that's why integration, looking at the standards, looking deeper is really, really important. Here we see electric car refueling station. They have this white concrete. This is a cloudy day, but any amount of sunshine and the parking is so light, it's almost blinding white. So they did a good job with being reflective, reducing heat island effect, but did they need to go that far? Because it's difficult to be walking through that parking lot from what I hear from the facility managers and some of the people that work in the store. So you have to be weighing your options, making sure you're being responsible, not just going to the extreme because somebody said it was a good idea. We have to be informed about our decisions. Be sensible. Measurement verification, this is important. You know, those energy models, as I said, can only do so much. They're a great estimate. They're great in informing design. It's important to do them early on in the process so you can be weighing options. That's when an energy model really has the best savings and impact on your project. But then afterwards, you need to go back and look how the building is actually functioning. What's the data? How are occupants using it? And then taking corrective action. And here the standard is the International Performance Measurement and Verification Protocol, IPMVP. A good way to remember this standard relating to measurement verification, MV, is right in the acronym. That's the only way I remember these things. Got to find little tricks for yourself as you get more familiar with this stuff. Green power. So we talked about renewable energy on site. Green power is renewable energy on a utility scale. So provide at least 35% of the building's electricity from renewable sources by engaging in at least a 2-year renewable energy contract. So if anybody says, hey, can you just buy LEED points? Not really, and not a good idea. But this one, you kind of are. You're investing in renewable energy. That's great. That's how we're going to push these things going further, new technologies. But this is actually just buying a contract with a program that is either selling green e-products, so they could be either renewable energy certificates, so something you buy and sell. The stock market is actually kind of picking up on this new commodity, so this is a real deal that's going to be part of our economy that is predicted to be seen at least. Center for Resource Solutions, CRS, good resource for these different options, green tags, tradable renewable certificates, all different ways to buy and sell this commodity. So once again, you can look at the Commercial Buildings Energy Consumption Survey. And what that is, it's a collection of a wide range of data that was collected in U.S. buildings saying on average how much these types of buildings use on an average per square foot. Or once again, you can use your energy model you use for energy optimization points. So here you see why Fred Meyers could get so much bang for their buck by being more energy efficient. This is information from the Commercial Buildings Energy Consumption Survey saying that food sales have the highest median electrical intensity kilowatt hours per square foot per year of any type of building. So if you look at something like that, that's why it's good to just look at the resource first and be like, well, apparently energy efficiency is our first thing we should look at because we are using a lot, most likely.